So in this video we will cover about current and its current source along with its combinations that are ideal and practical. So first of all, let's deal with the definition of current. So what is current? It is the rate of flow of electric charge in a conductor such as a wire, or it can also be said as it is the rate of flow of electric charge through a circuit. Any of the definitions would be fine. And the main 2 points you need to keep in mind is this current is measured in terms of amperes, and ammeter is used to measure current. Current is measured in terms of amperes and ammeter is used to measure current. The formula which we use to measure current will be I is equal to dq by dt into coulomb per second, which is measured in terms of amperes. So we represent it with capital A. So this is the concept of current, and let's now see about what is this current source and what are its combinations. So now we already know about this voltage source part. It has two combinations, which is ideal voltage and the other one is practical voltage. So in this particular case, ideal situations అనేవి they do not exist. It is only for just our understanding purpose. These ideal situations do not exist in the real world. So why? Because in this ideal voltage part we get Vs is equal to VL, which is source voltage will be equal to load voltage. But in the practical voltage part, yesterday what do we like in the video, we just derived this part. Vs minus ILR is equal to VL. This is the part which we derived, and this particular part is called as drop. Okay, so how can we make this practical part into ideal part? We'll just put internal resistance is equal to 0. If internal resistance is 0, Vs minus IL into 0 is equal to VL. So Vs is equal to VL. So we can make it ideal. This is the case with voltage source. Now keep this part aside. Now we'll discuss about current source. So current source also has two combinations, same as voltage. Here we will have ideal current and the other one will be practical current. Okay na? So both voltage source and current source are easy to understand if you are replacing the terms by voltage and current. Now let's discuss about ideal current source. So now let's see ideal current source. Ideal current source is nothing but it gives constant current. In the case of voltage, we have got constant voltage. So ikkada entante it gives constant current in the circuit even if the load values are changed. అదే ఐడియల్ వోల్టేజ్ సోర్స్లో ఏమవుతుంది, ఇట్ గివ్స్ కాన్స్టెంట్ వోల్టేజ్, అంటే కరెంట్ ప్లేస్లో మనకి వోల్టేజ్ వచ్చేస్తుంది అంతే. దట్స్ నథింగ్ బిగ్ రాకెట్ సైన్స్ ఇన్ దట్. సో నవ్ దిస్ ఈస్ ద సర్క్యూట్ we are having. Now this is the current source we are having and this is the current flowing throughout the circuit. This is called as the load current and this is called as the load resistance. So now IL is load current and RL is load resistance. Now according to the graph we can tell that if we change, what is he saying, if the load is changed also the current will be constant. Means I am changing, suppose if I am changing my load resistance value to 0, the current will be constant, there will be no change. If I change it to 1, the current will be constant, there will be no change. If I change it to 2, the current will be constant. If I change it to 5, the current will be constant. So in this particular concept, he is trying to explain you that if you give any change in the load value, the current will not change. It will be constant. So we can derive it in this way. So according to Ohm's law, we know that V is equal to IR, which means load VL is equal to IL into RL. This is the thing we have. Now, to get this IL, how we'll get IL? IL is equal to VL by RL. In this way, we can derive IL value, means load current value is generated by this thing. So if there is any change in this load resistance, automatically there will be no change in this load current, which means it will be constant. So this is the thing he is trying to explain you in this ideal current source concept. So let's deal with the practical current source now. So now let's see practical current source. So this is the circuit, this is the source current which I am having, and the current is flowing throughout this circuit. Okay, so this X is called as node, and this is called as our internal resistance, and this IR, this current is generated because of this internal resistance. We'll discuss it now. See, for example, here this is VL. VL is called as load voltage, and this load voltage is generated because of load current and load resistance as discussed in the past video also, and this is the concept we are having here also. So this load voltage is generated because of IL and RL. This is the case we have. Okay, this case was completed. Now let's keep this aside. Now let's discuss about this R part. This R is called as internal resistance. Now IR is the current generated because of the internal resistance. So IR will be your current generated because of internal resistance. Okay, this point is clear, I hope. Now what we need to do to find out the equation, we need to apply KCL, which is nothing but Kirchhoff's current law. We will not apply here KVL because this is current, so we'll apply current law. If it is voltage, we'll apply voltage law. So what will happen if we apply KCL? What is KCL all about? So KCL is nothing but sum of all the currents at junction will be equal to 0. This is nothing but KCL. Now how will you do that? See, so now my current is flowing. This is my source part. So from this particular part my current is flowing inside. Okay, or for example, I'll tell you an easy way also. KCL can also be derived as sum of incoming currents equal to sum of outgoing current. Okay, now see, so this IS is the incoming current at node X. So node X ఇది కదా మనకి, ఈ IS ఏమవుతుంది, ఈ నోడ్ X వైపు ట్రావెల్ అయిపోతుంది. సో నోడ్ Xకి నేను రీచ్ అయిపోయాను అంటే ఇక్కడికి రీచ్ అవ్వగానే ఏమవుతుంది, ఈ కరెంట్ అవుట్ గోయింగ్ కరెంట్ అవుతుంది, ఇది అవుట్ గోయింగ్ అవుతుంది. అంటే మన IR అవుట్ గోయింగ్, IL అవుట్ గోయింగ్ అని అర్థం. సో we can tell it as, so IS is equal to IL plus IR. Simple, that's it. So this is the equation we have. Now in this case, IL and IR are outgoing currents. IL plus IR are outgoing. Okay. Now how to get this potential drop? See. Now what I'll do, I need to equal it to the load current. So load current will be IL is equal to IS minus IR, and according to Ohm's law we have V is equal to IR, which means I is equal to V by R. So what will happen in this case? In this R case, we'll have IL is equal to IS minus VL by R, because here V is nothing but our load resistance and R is nothing but our internal resistance. So this particular part will be our drop value now. So this is how we generate this equation, this particular equation by using Kirchhoff's current law. Now let's see the graph of this particular concept. So now this is the graph we are having. EIS anedi current source, this is our load current, and this is our load resistance. So according to the equation we have IS minus VL by R is equal to IL. So this particular VL by R will be our potential drop, which is this particular thing. Ante enti nuvu RL lo nundi, see, from your source current, the drop value which you are subtracting will give you this particular load current. Ante nu IS lo nundi VL by R value ni subtract chestunnam enduku, to get this particular value. So that subtracting drop value will be our potential drop. So this is the graph we have. Now to make it practical, so what can we do to make it ideal? We have, see, we need to put R is equal to infinity. Why we need to take R is equal to infinity is, now for example if we are having VL by R, okay, so ఒకవేళ నేను R ప్లేస్లో 0 సబ్స్టిట్యూట్ చేశానంటే ఎనీథింగ్ డివైడెడ్ బై 0 will give you infinity, which is not possible for us. So if I substitute in place of R infinity, VL by R is equal to VL by infinity. So anything divided by infinity will be giving us 0. So directly then what we'll get? Then IL is equal to IS, because we'll substitute 0 in this place. So we'll get our load current and source current value as same. So this is the concept of current, and with this video we completed our discussion part of active elements. So in the coming video we'll discuss about passive elements. I hope you understood, and if you're having any doubt you can just comment down in the comment section. I'll try to clear your doubts. Okay, thank you for watching.